Okay, greetings all. Today we have a short discussion, just a short kind of a high level overview of the Unified Modeling Language, the UML. This is just a brief discussion and just a brief introduction. Our approach. So we'll begin the way we'll tackle this. We'll look at the background, where did the UML come from, and the motivation for doing it. We'll look at sort of, what is at a high level, what exactly is the UML? What is it and what is it used for? We'll go ahead, we'll answer that question, and then we'll look at some specifics. We will look at some specific UML diagrams. And just to sort of give you a preview of coming attractions, the UML, the Unified Modeling Language, it's a notation for designing software programs and software applications. So it's a platform-specific independent notation for designing software programs. It's finding its way to be used for more than exclusively software. People are using it for larger system architectures these days, but its first and primary use is for software programs. So let's begin, and we'll conclude with sort of a summary and some selected resources. You'll find there's many resources on the UML. I've cherry-picked a couple that I think are pretty good for you to use. So let's begin with the background and the motivation for the UML. So the UML, the Unified Modeling Language, it's very much been an evolutionary process, and it's a it's a notation for modeling software. But where did it come from? So here's this sort of busy, you can see this busy chart here. It came out of a collaboration between the so-called three amigos, Jim Rumbaugh, Grady Booch, and Ivar Jakobsen. And that collaboration took place in the mid-90s. And yet people really did call these guys the three amigos. Essentially, they all had their own similar methodologies under development. You can see here Grady Booch here had the so-called Booch notation, and you can see pre-1990 he was actually working this Booch notation for a programming language called Ada. Here you see Jim Rumbaugh had the so-called object modeling technique, and here, let me just erase this real fast. You can see Ivar Jakobsen had a technique as well. In the mid-90s, they combined elements of all three to come up with the UML, the Unified Modeling Language. So here you can see version 1 was in the mid-90s, and it has continued, it has continued to evolve up until today. And see, this chart goes to 2008 UML 2.2. It's evolved since then. Very briefly, you can also see, I mentioned earlier that the UML is finding its way into more than just software design. Here you can see there's reference to the so-called SysML, or System Modeling Language, which is built off of UML. So it's, it was developed for software applications, but you can see it's finding its way into higher level things. So essentially, the motivation was to provide a notation for platform-independent designs and specifications. So to take a little bit of a deeper dive on that, what is UML? Simply stated, UML, it's a graphical notation, and it's used for the design of software applications before coding. So a graphical notation used to facilitate the design of software applications before coding. And you'll often see analysts will create these UML diagrams, and then pass them to software engineers, pass them to an implementation team. Sometimes the folks developing these UML diagrams and these software design artifacts are not necessarily the same individuals that are doing the implementation. It certainly can be, but it doesn't have to be. Here there's a pretty extensive website, uml.org, that discusses this what is in more detail. It's a pretty quick read. I recommend it. The UML came out of the work of the so-called Three Amigos that we talked about earlier. It's currently maintained by the OMG, the Object Management Group. And the Object Management Group, reading straight from their site, here's how they describe themselves. They describe themselves as an international, open standards, not-for-profit technology standards consortium founded in 1989. So they've been around a while. And most people in the industry, certainly most software engineers know about the OMG. Some of you may remember Corba and some of the other things that they were pretty well known for doing. The current version of the UML is version 2.5, and it specifies 13 different kinds of notation, 13 different kinds of diagrams that are broken into 3 types. The so-called structural diagrams that define the sort of the static structure of a software system, the behavioral diagrams, and the interaction diagrams. The behavioral, so structural is kind of the static structure of a system. How is it put together? Behavioral, how does this system behave in the presence of so-called use cases when it's used? And interaction, how do the various parts of the system work together? Here's an example of one of the diagrams. This is one of the interaction diagram types, and this is a UML sequence diagram. To show you a little bit more extensive example, and this is admittedly, this is a pretty complicated example. This is a fairly complicated UML diagram. This is one of the structure diagrams. This is actually a class diagram. Each of these boxes represents a software class or a software interface. This particular structure diagram is a structure diagram for the Game of Life. The Game of Life is a popular cellular automata program that's been implemented hundreds, thousands of times. You don't have to look hard to find lots and lots of information on the Game of Life. And this particular design is by an individual, an analyst by the name of Alan Holub. And here, this is a link to Alan Holub's website. And in addition to this model diagram, there's lots and lots of interesting stuff on this site. And actually, one of your references that I show you at the end is actually, he's got a really nice UML guide. So let's look. Let's try to dive down just a little bit deeper, and let's look at some of these diagrams. We'll begin with the structural diagrams. Now there's 6 different, and again, these structural diagrams they're static, and they define sort of the static architecture, the static structure of a model. There's 6 kinds. There's class diagrams, object diagrams, package, component, composite, deployment. In my personal experience, by far and away, the most widely used is the class diagram, and this is a simple class diagram right here. what does this show? So here we have, and this is a class, a software class, and by class I refer to a class in the OO, the Object-Oriented Software Design and Software Methodology sense. So here is a class whose name is bank account. So this is the bank account class. And you see there's three compartments. The first compartment in the box here is the name of the class. The second compartment, these are the so-called members or attributes of the class. And this is showing us that we have an attribute called owner, and that the owner is of type string. So, you know, owner, the name of the attribute is owner. Its type is type string. So this might be, you know, what might the value of something like this be? You know, it might be Jane Doe or John Smith or something like that. We've also got another attribute, an attribute called balance. And balance, here we have, what is the type of balance? We have a custom data type here called dollars. And furthermore, we're going to initialize this dollars attribute equal to 0. And you know, obviously in a real bank account you'd have many, you know, you'd have many more attributes here. This is just an example to show you how to show you the structure of a structure diagram, to show you the structure of the class diagram. The third compartment down here, these are the so-called methods of the bank account class. So classes have you know, members or attributes. That was what we talked about here, and they have methods. So here we've got two methods. We have a method called deposit and a method called withdraw. And the deposit method takes an argument of type dollars, whose name is amount, as does the withdrawal method. The withdrawal method takes an argument named amount of type dollars. So that's, and it's really not much more complicated than that. You know, there's nuances and other features we haven't really talked about here, but this is essentially how class diagrams work. So they're straightforward, they're simple, they're graphical, they're easy for people to kind of remember and easy for people to use. Moving on, let's talk about the behavioral diagrams. So the behavioral diagrams, there's three kinds: the use case, the activity, and the state diagram. And the use case, the behavioral diagrams are meant to model you know, how the system behaves in the presence of external stimulus. How do the so-called, when a user interacts with the system, how does it respond? How does it behave? Now think about how this is used. This is a pretty effective design and modeling technique. We want to describe in an implementation agnostic kind of way how the system responds. What is the system supposed to do? And this is you know, at the domain level. It's not about writing code or implementation. It's how should the system respond, and it's enormously important. Our example here, this is a use case. This is a use case diagram, and this visual diagram, it's basically it's got these stick figures are the actors, and the uses here are use cases. Here are the different uses, and the idea is to try to model at a high level the interaction between the users and the system. So here, who are the actors in this particular example? So we have a waiter, we have a client, we have a cashier, we have a chef. Now some of these things are going to seem, and what are we trying to model here? You know, this is like a restaurant. Some of these might seem really obvious to you. When in doubt, when you're doing modeling and specification, even if it seems obvious to you, write it down. Write it down. Don't assume that others are going to, I need to write that down. I just know that. It's a classic mistake that's made in design of systems. So write it down even if you think it's obvious. So what are the things that waiters do? Waiters participate obviously in the order food, the order food use case or the order food process. What do? They receive the orders. They place orders. They participate in this serve food case. So they also participate in the pay, in the pay for case. They take your money or your credit card. The client, what does the client do? The client also participates in the ordering process, so you have to take that into account. Client eats, the client drinks. So eat food, drink wine, drink Coca-Cola, whatever the case may be. The cashier accepts payment. So the cashier is a participant in this pay for food process. So this pay process, simple as it sounds, you can see 3 different actors in the system. The waiter, the client, and the cashier participate in this pay process. And let's not forget the chef. The chef cooks and orders. The chef cooks the food and obviously participates in the order food process. The chef ultimately receives the order. Now, is there more to a restaurant than this? Of course. And can some of these diagrams, some of these use case diagrams get pretty complicated? They can, but this is the idea. And again, these are pretty simple, pretty straightforward as well. And the idea is for these things to be effective, try to keep them simple. It's understood that not all use cases are that simple, but when you can, try to keep things simple. One more fundamental type, there's the so-called interaction diagram. And the interaction diagram, these are pretty useful in my personal experience. You capture the different kinds of interactions. There's 4 kinds of interaction diagrams: the sequence diagrams, communication, timing, and a so-called interaction diagram. Here, this example, whoops, I got ahead of myself a little bit. This example is a sequence diagram, and it is a simplified sequence diagram, but this is a sequence diagram from a pretty classic design pattern called model view controller. So this is a pretty classic design pattern, and this is a simplified sequence diagram for this so-called MVC, model view controller design pattern. How do we read this? So here, the way we would read this is the controller. So let's say we have a controller object, a model object, a view object. So the controller, in this case, invokes the add listener method of the view object. So here we're saying that the controller invokes the add listener method of the view object. The user asynchronously enters a number, and subsequent to that, the view notifies the controller that an event has occurred. The user has done something. So the view invokes the number entered method of the controller. So here we began the controller invoked a method on the view. The user did something, and here the view invokes a method on the controller. Next we have the controller. So the model in a MVC, model view controller system, the model is where the work is actually done. So the controller initializes the model with this set number method, and this is the number that the user entered. And this is a model view controller simplified version for a number problem of some kind. And then the controller invokes the solve method of the model. Now, the solve method will return a solution to the controller, and the controller will then invoke the display result method on the view, and the view displays the result to the user. So there's a sequence diagram for model view controller. These sequence diagrams, I've used these many times. They're very, very useful. A really useful diagram. Here's sort of the class diagram for the model view controller that we just looked at. You can look at this sort of offline, but you'll see these methods or names that are pretty similar to the methods shown on the sequence diagram are also represented in this class diagram. So here's the structure diagram, and just to go back, this was the interaction or the sequence diagram for that system. So, quick summary. UML, it's a graphical notation used to facilitate facilitation of the design of software applications before coding. It's maintained by the Object Management Group, the OMG. 13 kinds of diagrams: structural, behavioral, and interaction diagram, and resources. What is UML? So this is from the uml.org. Spark systems, which some of you may be familiar with. They have nice tools for software architecture and system architecture. They've got a nice UML tutorial. IBM has great tutorials and great resources. So there's a good IBM tutorial on UML. And as I mentioned earlier, this Alan Holub quick UML reference. Alan Holub is an object-oriented analyst and designer, and he's got lots and lots of interesting and useful material on his website. So there, we'll leave it right there for now. There is a quick overview of the UML with suggestions for where you can go if you want to take a little bit of a deeper dive. Okay, have a great day, everybody.